Hey sister friends, I hope your quiz went well. Today we are going to start some rational inequalities and we'll finish up talking about these tomorrow, or well, the next time that I see you. Okay, so similar to what we did in polynomials, we're going to draw a number line, put down our critical numbers and figure out where is it above zero, where is it below zero. But for these rational graphs, we're not going to actually graph it like we did for polynomials because that would take forever. So what I'm going to do first is draw my number line. Cute. Okay, so now I'm going to put in my critical numbers. So in my numerator, I have my x-intercepts. In my denominator, I have my vertical asymptotes. So my vertical asymptote here, if I solve, is positive 1 divided by 2, so I'll have 1/2. And then my two x-intercepts would be negative 1 and positive 3. Sometimes I like to write them out first because then when I go to my number line, I have to put them in order from least to greatest, obviously. So we have negative 1, we have 1/2, and we have 3. Okay, so now we need to decide if these are open and closed or closed points. This is different from polynomials because I can't just look at the inequality. I have to look at what are these numbers actually. An x-intercept actually touches your graph. So the 1 and the 3 are actual points on your graph. But your vertical asymptote, your graph doesn't actually touch. So that gets the open point. So intercepts are closed points, asymptotes are open points. That's how we'll do those. Now what we're gonna do is pick numbers between each of these sections to then figure out if it's greater than 0. So I'll pick 4 over here. Let's pick 1, that's the easiest number. 0's between here, and then I'll just pick negative 2. So these are the numbers that I'm gonna plug into the equation to see if it's bigger than 0. So a little shortcut for you, when I plug in a 4, I don't care that this number, when I plug in 4, is 26 over 7. I don't care about that. All I care is if it's positive or negative. So the way I like to evaluate this, so I'll kind of make my fraction, because I have a fraction. If I plug in a 4, that'll be 8 minus 1 to the 4th power. I don't care what that number is, but I know it's positive. Okay, because all I care about is positive or negative. Then I'll do this little section. 4 plus 1 squared. Squared is also going to make it a positive, whether it's negative or positive. 4 minus 3 is 1. 1 cubed is still a positive 1. So I have all positives here, so this section is positive. If I plug in a 1, 2 minus 1 to the 4th power will be a positive number. 1 plus 1 is positive, squared is still positive. 1 minus 3 is negative, cubed still keeps it negative. So this whole section, since you have a negative, is negative. Plugging in a 0. 0 minus 1 is negative 1, but a negative to an even power becomes positive. Okay, plug in a 0 here. 1 squared is a positive. But plugging a 0 here, a negative cubed is still negative. So again, this whole section will be negative. Okay, plugging in a negative 2 makes the parentheses negative, but when you put it to the 4th power, it becomes positive. Negative 2 plus 1 is also negative, but square it, it becomes positive. But in this parentheses, it's negative, cube it, it will stay negative. So this whole section is negative. So now I have all of these sections. I have 3 negatives and a positive. So what I'm gonna do is highlight where is it greater than or equal to 0. So greater than or equal to 0 will be the positive section. So that's here, that's the only positive section. However, I also have to look at the equal to because it's also equal to 0 just on that point right there. So whenever we go to write an inequality, I'm gonna write from least to greatest. So the first thing is the negative 1. Well, negative 1 itself isn't an interval. So the way that we write just a number itself is with these little pretty brackets. So I'll put negative 1, union, and then I'll write my interval, hard bracket 3 to infinity. Yay! So again, if you just have a number when it's just the equal to, you just use the little pretty brackets. And then we used a hard bracket for 3 because it was a closed point and I wanted the equal to. Okay, let's do one more together. So on this one, we have to do one extra step. We need to factor that denominator. So we'll have x plus 1 over x plus 3, x minus 3. So when I go to my number line, I'm doing -3, -1, and +3. The two asymptotes are the 3's. That's where they get the open point. The -1 is the intercept, so she gets the closed point. Let's pick some numbers in between. So we'll do 4. Let's do 0. The only number is -2 to choose there, and -4. So same thing as last time. Let's plug in these numbers and determine if each section will be positive or negative. So if I plug in a 4 here, that's positive. Plug in a 4, that's positive. Plug in a 4, that's positive. So this whole section is positive. Okay, let's plug in a 0. Plug in a 0, positive. Plug in a 0, negative. Plug in a 0, positive. Since I have a negative, this whole section's negative. -2. If I plug in a -2 here, +3 will make it positive. -2 minus 3 is negative. -2 plus 1 is negative. Okay, so for this section, 2 negatives cancel to make a positive. So this whole section is still positive. Plug in a -4. -4 plus 3 is negative. -4 minus 3 is negative. -4 plus 1 is negative. 2 of these negatives make a positive, but you still have another negative, so this whole section is negative. Okay, now I'm going to highlight what I want based on my inequality. So I want my graph to be greater than or equal to 0. Here's my only equal to 0. So let's look for greater than. So that's the positive sections. That's here and here is positive. So to write my inequality, I'm going to go from left to right, least to greatest. -3 will be a soft bracket, a parentheses, because it's an open point, to -1, hard bracket. Union, let's pick back up at 3 to infinity. And that's it. What I want you to work on now are these 4 problems, and we'll discuss them tomorrow. See you later.